Okay, today we're going to talk about war. So a long time ago, maybe 1,000, 2,000 years ago, before a lot of technology or mechanical advancements were around, when people were fighting, different groups of people, countries, towns, whatever, generally speaking, whichever army had the most people was the victor. So, for example, if you have 1,000 people fighting for you, and the people you're against have 10, it's unlikely that the 10 people are going to win, because you're so much larger of a force than the other one. Does that make sense?
Unless they're Spartans.
Okay. So, when you talk about that, and you look at something like 1 million versus 3. The 3 is insignificant. And when we talk about that, that means that the million's going to win. It overpowers the 3. As I talk about today's lesson, I'm going to refer back to this kind of information so it makes sense to you. All right? Now, when I look at this in terms of algebra, and I think about numbers, like, for example, if I think about x and plugging numbers into x, like that million I was just talking about, that million compares to x and x squared a little bit differently, of course. So if I stuck in the million for x, that means I have 1 million. But if I stick in the million for x squared, I have a 1 with 12 zeros. And that million is pretty insignificant compared to the 1 with 12 zeros. Does that make sense to you guys? So when you have a power that's bigger, the value that you shove in for x explodes compared to everything else around it. So if I was talking about an expression like x cubed minus 1 million or something x plus 500,000 or some other big number, the only thing that's going to matter here is I'm going to an infinitely large or infinitely small number is the x cubed thing, because it grows so much faster than the other two things. Does that make sense? Like if I pick in the number 1 billion and I cube it, compared to what's happening with the x and the 500 or 5 million, excuse me, the other two things don't even matter when you're going to an infinitely large or small number. And today we're going to talk about limits at infinity. So what I want to tell you first of all, and most importantly, is that we're talking about only when we're going to infinity. What this means is that my x is either approaching a positive infinity or my x is approaching a negative infinity, which means a very large positive number or a very large negative number. So as I look at the very first example, and I'm going to skip graphing it, you can type it in your calculator and look at it yourself if you want to. I want to talk about what happens. What they're saying is, I'm going to, in the first place, shove in something very large that's positive. Just as an example. If I shove in that large positive number, what I'm talking about is that this 1 that's on the bottom, when we were talking about war, let's say I shove in a positive 1 million. On the top I would have 2 times 1 million, that's 2 million. On the bottom I'd have 1 million plus 1. 2 million divided by 1,000,001 is roughly, no, is roughly 2. 2 million over 1,000,001 is about 2. And if I go with 1 billion, 2 billion divided by 1,000,001 is even closer to 2. Does that make sense?
Yes.
If I put in a negative 1 million, 2 times negative a million is negative 2 million. Negative million plus 1 is negative 999,999. That's pretty close to 2 again. So no matter what I do, that 1 that we were talking about is insignificant. Because on the top, the thing that dominates is the 2x. It's the only thing up there. But on the bottom, the x dominates. So really what this is talking about in the red is the limit as x is approaching positive infinity of whatever the function is, but we're only going to consider the 2x on the top and the x on the bottom. And we can tell that those things, when we're looking at them, the x's cancel out, and you just get 2. So the limit as I go to positive infinity is just 2. And if you were to work with the negative infinity, you would see the same thing. You would see the limit as x is approaching negative infinity is really like saying 2 times x over x again, because that 1 means nothing on the bottom. And then you still get, in this case, a 2. Because the x's, just like they did previously, reduce. So when I was talking about war, what I'm trying to tell you is, when you see more than one thing in the numerator or the denominator of a fraction, only worry about the largest thing there. So if I were to put this in my calculator, just to take a quick look, in my y equals, what was my function again? So here we are. You can kind of see one of those 1 over x kind of graphs. And you can look at, as you go off forever in the x direction towards the positive values, that your y value, which is a limit, is approaching 2. And even as you go off to the left towards the negative x values forever, same thing is happening. If I kind of wanted to check that on my calculator, I could do that in my table. You can go to your table set. You could start at wherever you want to, doesn't really matter. But instead of doing that, I'm just going to go with Ask Auto, because I find that to be easier. And then I go into my table, and let's type in a really large positive x value, like 100. Oh, look, I get the number 1.98. What if I go larger, like 1,000? Then I get the number 1.998. And if I go to 10,000, it gets even closer to 2. I could go with a bunch of zeros. And you'll see the number 2. Now that probably actually is not a 2, but so you can see the value down here. But it gets close to 2, the y value. And I could pick negative values as well. Like I could pick negative large value. And you still see, uh-oh, you see an error. Oh my goodness, that's annoying. Eat it. There we go. And you see it too. Okay, so either way. Okay, so now there's some kind of nice rules about what happens.